Hey, good morning everyone, or in fact maybe good afternoon. I'm sorry I couldn't make it this lecture, especially the very first week, but I'll see you next week for sure. And today I am actually now, in fact while you're listening to this lecture, I am at a very related conference to this class. It's called Transportation Research Board, where I'm presenting few papers regarding pavement management systems and pavement engineering in general, and I'll give you a brief idea when I get back of what I did during the conference. So with that, again the class is CENG 5350 and is pavement management systems. So let's get started. So those are the major topics that we're gonna cover in our class this semester. So we're going to start with a brief introduction by pavement management systems, how does pavement fails, and what type of failure does flexible and rigid pavement see, and then we're going to move on to the pavement management system levels and functions. Then we're going to cover the development and management of a database, and then payment performance and failure criteria, and then how can we manage payment management system databases, and we're going to also perform what we call analysis or life cycle cost analysis, and then we're going to finish with maintenance, rehabilitation, and reconstruction prioritization. How can I come up with a plan to maintain my network? So with that, let's start with the first chapter. Chapter 1 is an introduction and background behind the concept of pavement in general and pavement management systems in particular. So as you could see, this is really a schematic that shows the importance of our transportation facilities. As you see, the infrastructure in the US is really the basis of our economic system and has a direct bearing on our capability to compete in the international economic system. As you could see, behind or in front of the natural environment, we have our physical infrastructure. After the physical infrastructure, we also system as well as the social system. So it is really the base of our economic system, and it's very important to keep this infrastructure network functioning in the best case scenario. This is here basically this reference that I'm gonna give you here shows the interest of the private sector in the highway transportation system. In fact, this document describes the close link between the highway transportation network and the economy. Using this quote actually would give you an idea how can the transportation facilities will have a great link between the network as well as the economy. So Osmond and the critical link, and that's a book, or in fact a publication that was done in the 1991. It was mainly a message on the importance of the highway infrastructure to the U.S. economic growth and productivity that really was presented at the Highway Users Federation 1991. Some of the quotes that I picked from this publication. So the very first one, very, very important. Just as a conveyor belts link factories internally, so must highways link supplies and customers. This is really what, in fact, in another course that in semester we call transportation systems is a derived demand. I don't like, or I don't want to just drive, let's say, from Tyler to Dallas just because I like to drive. No, there is a reason behind it. You would go there for work, leisure, or get a flight from Dallas Fort Worth. So it's really a link between the supplies and the customers, which are us drivers. So without a modern and expanding highway program, we will be unable to compete. That's a huge point that I want to emphasize on. Again, this is how we compete against other countries, is the strength of our transportation systems. How can we move goods in a safe as well as an efficient way from point A to point B? That's why our infrastructure drives economic growth and productivity. If we should ignore this critical link, our country could lose its competitive edge. Also, the last reference here, or the last quote, says if the American economy is to continue expanding, which is a good thing, we must ensure that we have a transportation infrastructure able to maximize the efficiency of the American industry. So again, they go parallel, economy as well as the strength of our transportation infrastructure. And that's why we are much interested to study on how can we maintain and even improve our transportation facilities. So, talking about transportation facilities, what is FHWA? And in fact, I'm going to ask you in exams or quizzes with several acronyms and what do they really mean. So, Federal Highway Administration, FHWA, really classifies our roadways by their function within the state's network of public roads. So we may basically have local roads, collect all the way to arterials, and eventually arterials will link to highways or freeways. So what do I mean by each one of those? So the very first one is the local road. Local road, basically those are the small roads that serves homes, businesses, farms, or even small communities. And basically the major goal behind having local roads is to provide access to the bigger roads, which are the collectors. So going to the collectors are a channel traffic from, so it's basically connects a small roads all the way to the arterials, where the arterials are really supposed to provide a safe, reliable, and efficient travel between large towns and major cities. If you can, I'm pretty sure now you start thinking of examples for local roads, for example, or University Drive, all the way to the collectors. I would say a good example would be the Loop 323, all the way to arterials. Arterials can be one of the big routes that can connect, let's say, Tyler to smaller cities close to it, like Kilgore or Longview, which is eventually is going to connect to a major freeways like I-20 or US 80. Okay, and the other entity that also deal with highways and highway networks is the U.S. National Highway System, NHS. The US NHS is simply a network of roadways that is important to the nation's economy, defense, as well as mobility. It really includes a lot of different highways. It includes all interstate highways, which are arterials. It also includes the strategic highway network, which is for defense purposes, and that's why the Federal Highway Administration funds those roads, because the condition here is they can be used in the time of war. Also, the NHS network includes any intermodal connectors, such as roads that connect to major intermodal facilities and any other arterials. So here to give you again another perspective of the how many thousands of miles. So as of July 2008, NHS includes more than 160,000 miles of highways. And those 160,000 miles of highways, they are distributed into four major groups, if you will. We've got about 30,000 miles of rural interstates, 16,000 miles into urban interstates, 82,000 miles for rural other than interstates, and 34,000 miles for other urban streets rather than interstates. So there is a huge amount of thousands of miles that we as a pavement engineers, we need to keep those in the best case scenario and the best case conditions, so that we will be able to move goods and people from point A to point B in an efficient and safe way. Another perspective here of looking at the public road measured in center line length and lane length. As you can see here, this is history from 1985 all the way to 2006. And the yellow and the yellowish or the orange line indicate to lane miles, while the black line indicate to center line miles. As you could see, one of the things that you also would notice in the y-axis to the right, we have the lane miles in millions, and the y-axis into the left, as we have the center line miles into millions as well. So as you could see, miles are increasing every year. Every year we are building new roads as well as maintaining the new and the old roads as well. So one thing that is interesting, and you would see that yes, this place here after 1998 there's a drop. So what happened? Okay, so after 1998, forest development roads ceased being treated as public roads. This is why the figure indicates significant drops in both center line as well as lane mileage in 1999. But after that, again, the the lane miles as well as center lines also pumped up again, and now it's increasing and back to the increasing trend since 1985. Another chart here, which is kind of interesting, based on the public road ownership, and based on 2006, we have about 76 owned by local governments, 30% owned by the federal government, and 20% owned by state governments. That's actually not surprisingly that the majority of the public roads, which are about 76%, are owned by local governments. Approximately 3% only for roadway owned by Federal Highway Administration and governments, which are located mainly in national parks, forests, military bases, as well as Indian reservations, while state governments own the remaining 21% of public roads, including most of the interstate highways. Another chart here, another table that also shows you that altogether in the US there are 65% of paved roads versus 35% unpaved roads. You may think that we have our network almost completed and all the roads in the country is paved, and the answer is no. In fact, just 2/3 of the network is covered by pavements, mainly either asphalt or concrete, but there is still 1/3 is not paved yet. So don't worry, you will have a job for the next 10, 20, 30 years, because we need to pave those remaining unpaved roads. So as I said, in other words, the lane miles refers to the total length of all lanes under consideration, while the center miles refers to the number of miles along the center line of a road, regardless of the number of lanes it contains. So that's the difference between what's the meaning of center line miles. Okay, also an interesting facts regarding our transportation system. Flexible pavements comprise about 93% of the US paved roads and highways. When I say flexible pavements, I hope by now you know what do I mean by flexible pavements. Flexible pavements are asphalt concrete, asphalt pavements, not rigid pavements. Rigid pavements are Portland semi-concrete. The easy way of distinguishing between flexible and rigid pavements is the color. If you see a black surfaced pavements, this is asphalt or flexible pavements. If it's white, this is Portland semi-concrete. So 93% of our network are paved using asphalt versus 7% only using Portland cement concrete. And I'm happy with that because my interest is pavements, which is, to be more accurate, flexible pavements. When it comes to airports, about 85 to 90% of all runways at the nation's 3,364 commercial airports are surfaced with hot mix asphalt. And it's run by FAA, the Federal Aviation Association. So also there is a big chunk of the airports are covered and surfaced by hot mix asphalt. Another some fun facts about pavements and how do we see it on our daily lives. Busy commercial airports that some of you might have been visited and used, such as in Boston, Las Vegas, Newark, Oakland, San Francisco, or even Toronto, have main runways surfaced with asphalt. In fact, even the ones who love NASCAR, out of the 34 NASCAR race tracks across the country, 31 of them are paved with asphalt surfaces. So again, this shows you the emphasis on using pavements, mainly asphalt pavements rather than Portland cement concrete. Okay, so the question now becomes, okay, if we really have lots of pavements and mainly asphalt pavements, how can we measure how good is that road? One of the indices that we will learn in this class, and we will learn how it's measured and how can we use this number, is what we call the International Roughness Index, IRI. It's really one of the most widely used measures of the quality of ride smoothness. And again, bear with me now with the numbers and what does that mean, what's the unit mean, but for now the IRI rating, if the IRI number for any road is less than 95 inch per mile, that means it's very smooth. That means it's a good or very good ride quality. If the IRI is somewhere between 95 and 170 inch per mile, that means it has an acceptable ride quality. While if the IRI now is the roughness is increasing, remember it's called International Roughness Index. Now if I'm having rougher and rougher surface, IRI is more than 170 inch per mile, that's a poor ride quality and it has to be considered as failed section, or we need to do some major reconstruction or reation. Another figure that I want to share with you also, the overall health of our network. So when it comes to networks, we have about 78% are in a good shape, 20% are in acceptable shape, and 2% in a poor. While when it comes to urban, 60% only are good, 34% are acceptable. When I say acceptable, they really need some good amount of work as well, and 6% are poor. So there is a lot of work that need to be done to keep maintaining those roads. The good roads, the 60% in urban or 78% rural, they will not be good forever. They will change and their quality are gonna degrade by time, and that's why payment management system is gonna become handy to manage the system. How can I spend the amount of dollars that is assigned for me to keep my network in my city or in the state in an acceptable rate? Improve. For example, in the rural roads, how can I increase that good roads from 70 to 85%, and the acceptable roads, and instead of just 20, I'll make them 21, and the poor, I'll drop it to 1% or even less than 1%. So that's what we're gonna learn in this class more and more. So speaking of smoothness, let's see how good are all the states in terms of smoothness by state. So First of all, here we have the states in the y-axis, and in the x-axis we have how many miles. And as you would expect, Texas has the highest amount of paved miles in the nation. So Texas is here. We have about well more than 2,100 miles. 2,100 miles in good conditions, while we have almost another 1,000 miles in acceptable condition, while there is less than very little amount they are in a poor condition, which is good. But again, those yellow acceptable miles, 1,000 miles, need to be improved, because eventually they will be in a poor condition if we're not maintaining them on a good basis, maybe every year or every other year. Even the green ones, the good ones, some of them are going to turn to be acceptable in 1 or 2 years, and that's why we need to keep on maintaining those roads. Another chart here is the highway-based industries account for about 11% of our GDP. So what is GDP? GDP is the gross domestic product, or gross domestic income. The GDP is a basic measure of country's economic performance. Is the market value of all final goods and services made within the borders of a nation in a year. So out of our nation's GDP, as you can see, there is 10%, or even a little bit more, about 11% of our GDP is coming from the transportation system. In fact, also there is about 10 million people are employed in transportation related industry. So this really shows you how important the transportation industry is to our country. It just comes fourth place after housing, healthcare, and food. So it is really one of the big necessity, which is even comes before education itself. So again, this is to give you the perspective how important and how effective transportation system is on our daily life, and how can the way we can keep this system is crucial, and it's really our job as pavement engineers, as an civil engineers in general. So another some facts: taxes paid by the transportation industry amounts to 14% of all federal taxes and 23% of state taxes. It's a big amount of government or to our states goes to transportation industry. For all states, it's about 1/4. And so how much money and budget we need to reserve to maintain our transportation system.
Okay, another interesting figure here also that shows the highway expenditures in 2006. The government, the federal government versus state versus local governments, and how many dollars and billions are spent. So the federal government put about $2.19 billion, which is about almost just 1% of the amount of dollars that is spent during that year, while state put about $100 billion. About 2/3 of the amount of dollars that we spend on our network comes mainly from the state, while 36% of the money that goes into our transportation system comes from the local government. Also here the figure shows, in fact, the two red lines, those are the federal funding as well as expenditures. Again, when it comes to the federal expenditures, it's been really constant from the 70s all the way to our time,
it's about 1 or 2% max, doesn't really change, while for state, which are in the blue lines, or as well as the green lines, which are the local, in terms of billions of dollars every single year to maintain the payment system and transportation system in general. Another figure here, again, this is the highway expenditures based on state disbursements for highways by type of dollars in 2006. California comes first this time, more than $10 million, and then Texas comes second. And as you could see, the major contributor to the amount of dollars spent are capital, which means the major reconstruction, versus maintenance comes second. And then you would see that grants to local governments maybe the third, as well as enforcement and safety or bond retirement. Those really range back and forth, but the major are the capital amount of funds. Capital, again, those are costs associated with land acquisitions, design, construction, reconstruction, resurfacing, rehabilitation, while maintenance is, as it says, it's self-explanatory. It's just expenses associated with activities to keep highway in usable condition. Number 3 is administration and research, where again it's very minimal and it keeps decreasing and decreasing by time. This is one of the first things that they cut when it comes to budget cuts. So, but low, again, it's very important to keep research, because this is what really is going to improve all the way to local governments, which is basically a transfer of funds to the local governments. So again, this is in terms of percentages. So looking into Texas, which is here, Texas has about more than 60% coming from capital disbursements, and it comes the second place, it comes the maintenance, then we see the enforcement and safety, followed by grants to local governments, and then again bond retirement will come last. Okay, so giving you another perspective here from the interstate highways. Interstate highways really receive substantial federal funding. So as I told you before, this is what's the major amount of funds come from Federal Highway Administration. 90% are federal and 10% only are state, and those comply with federal standards. So what happens is the Federal Highway Administration decided to fund those national national highways or interstate, so that they will be used in the case of wartime. So, but one of the conditions that states has to follow are they have to comply with federal standards. For example, recently in the last 10 years, the Federal Highway Administration has been pushing towards using international systems or international units, such as meters and millimeters instead of feet and inches. So any bridge or any has been designed even by state officials or cities, but it's funded by Federal Highway Administration. It needs to comply with those standards. Interstate highways are owned, built, and operated by states or toll authorities, even funded by the federal government. Another perspective when it comes to the management needs. So highway agencies have been using various methods to manage this fund. The question here is, how can I, if I have that, let's say $1 million per year, can I make use of that $1 million in the best way possible, so that I can meet the highway needs within our jurisdiction? So construction of new roads were probably the best managed, with planning groups being developed in larger agencies to address where new highways would be built and to determine which should be funded. So coming up with a new construction is an easy thing. What's the hard part, which we're going to talk about, this is what handles, is how can I maintain the current roads. And this is even the tougher job. So, and that's what I'm mentioning in the next slide, is really maintenance and rehabilitation are managed with less formal methods. There is not much of well-established methods that tells you, okay, this is the way to go, or this is, you need to do this or that. It's in fact, in several cases, crisis management developed, especially in smaller agencies, as the standard method to address maintenance needs when funds are short. So, and that's again where the payment management system comes handy. Therefore, in the last 20 to 30 years, payment management systems have been developed to help plan the maintenance and rehabilitation of payments. How can I make sure that the money that I have is sufficient to maintain my transportation network in a good condition for the years to come? So when I say systems, they have to be, they are very necessary to avoid crisis reactions in public works. They are those management systems are really the true application of systems engineering and basic management concepts to manage the infrastructure, and eventually they would really provide a structured way to help get the most spent on the infrastructure. So this is actually the end of the introduction part of the chapter 1, and I hope now you appreciate the fact where I came from, very general information, all the way to reach the point that yes, constructing a new road is easy. Maintaining the road and what type of methodology that you are going to use to maintain and keep up the transportation system health is not an easy job, and this is where payment management system will come handy, and the tools that we are gonna learn along the semester are gonna give you some of the answers on how to maintain a road in a very good conditions. With that, again, I finished the introductory part, and we will meet next week to talk about the next topic, which was much more interesting, is how do payment fails? What are the common problems or distresses that hot mix asphalt or Portland cement concrete faces in our network? With that, again, thank you, and I'll see you next week.